Okay, so for this video, we're going to talk about series circuits calculation, specifically for total resistance, total current, and total voltage. You're typically going to be given a problem that looks like this. For the given circuit, solve for the total resistance, total current, and total voltage drop throughout each resistor. So looking at this image, you see that there's a battery. So there's a battery right here. There's 1, 2, 3 resistors. And what they don't tell us is the current, but that's okay. We'll figure it out. So you can look at the Project Lead the Way equation sheet. That's all in there. But for a series circuit, some of the rules that we have is that the resistance total, or the RT, is equal to the sum of all the resistors. So what that means is R1 plus R2 plus R3 plus R4, etc. So however many you have. And for voltage total, that's actually going to be just the sum of voltage 1, 2, and 3. So volts 1 plus volt 2 plus voltage 3, etc. So any batteries that you have, things like that, it will be entirely the sum. And in addition to this, we have current. So the current total is actually the same across the board. So I1 is equal to I2, which is equal to I3. And one way to know that this is a series circuit, and one way to know that this is the current is same throughout, is just looking at the path. So if we look at the path of this circuit, there's actually only one path that it can go. So in parallel circuits, it's actually going to have another path that it can go, but in this case there's actually only one. So that's how you know that this is both a series and that the current is the same throughout. And in order to find the current, the important thing is that you write out your knowns and your unknowns. Now the easiest way to do this is to create a chart. So I love charts and I love organization, so I'm actually going to create one right now. And I would recommend that on any test or any physics/engineering problems that encounter this, and there's a lot of numbers, organizing it out will help you solve it. So I know that I have 3 resistors, so I am going to draw 4 because at the top I want to also include the total. So let's go with my resistance total, current total, and my voltage total. And I also have R1, R2, R3, I1, I2, I3. So that's the current at each of the resistors, and the voltage at each of them. So as far as my resistance total, all I have to do is add up all of the resistors. So looking at this equation right here, I just add up all of the resistors. And in this case, I have 10 ohms plus 12 ohms plus 14 ohms. And if I were to add that up, I believe that is 36. So I would have a resistance total of 36 ohms. Now, for my voltage total, I only have one battery here. So that would be 45 volts. And I actually did not write out the resistors, so let me go ahead and do that as well. 10, 12, and 14. So now I have most of the things filled out on the left. Now I'm missing the current total. And if we go back to the Ohm's law video, we know that we have this triangle, V, I, R. And to find I, I'll use the same red to cover it up. I have I is equal to V over R. And I know my voltage and my resistance, so I can just go ahead and plug and chug. 45 volts divided by 36 ohms. And this is equal to 1.25 amps. So I know that my current total is 1.25 amps. so I have that out of the way now. That 1.25 amps is my current. And if I look at the rule right here, it actually says that all the currents are the same. So my currents are actually going to be 1.25 straight down the board. So what that means is that I have 1.25 amps at this point, and at this point. So throughout the entire series circuit, it's the same, 1.25 amps. And to solve for V1, V2, V3, or voltage 1, voltage 2, voltage 3, I essentially just have to do V is equal to IR for every single one. So when I have the equation V is equal to IR, and I want to plug that in, and I just know that at, let's say, that first resistor, I have a resistance of 10 ohms, and I know that I have a current of 1.25 amps. So I would get a voltage at this point of 12.5 volts. So 12.5 would be my voltage at this point. And I would go ahead and actually do the same for every single one of these as well. I'm actually not going to show that on video, but feel free to calculate it and check it with your work. But here's the big thing for the volts. Since you didn't know it before, what you would do is you would actually have to calculate all of these. But to make sure that it's correct, I would go ahead and always add up this, and add up this. So when you add them all up, they should equal to the voltage total. So 12.5 plus 15 plus 17.5. So if I were to plug that in, and let me go ahead and erase this. Let's say I have all my numbers, and when they add up, this should equal 45 volts, and it does. So I know that this is correct. So these three are correct just based off of my adding them all up. And that's a cool thing about this. You can double check with anything just by adding them all up. And there you have it. This would be how you solve for the total resistance, total current, and total voltage drop throughout each resistor.